Good morning everyone. Welcome back to the course Engineering Chemistry. Myself Dr. Harika Patnala, Assistant Professor, Department of Chemistry, MLR Institute of Technology, Hyderabad. In previous class, we have discussed about the classification of batteries, primary battery, secondary battery and the reserve battery. In the continuation, in today's class, we are going to discuss about the Lachance cell. Lachance cell is a primary battery. Let us see the overview of Lachance cell. This topic includes construction of Lachance cell, working and applications. Lachance cell is a primary cell. The Lachance or the zinc carbon tricell. Among the tricels, Lachance is one of the tricell and mostly used and widely used battery. It is a battery has existed for over 100 years and has been most widely used of all the tricell batteries because of its low cost, relatively good performance and readily availability. It was readily available in many sizes. In many sizes, it is readily available. Many sizes and characteristics required. Need to meet the various requirements in wide variety of applications. Wide variety of applications. So it was available in various sizes and characteristics. Need to meet the various requirements in wide variety of applications. What is the chemistry of the Lachance cell? It consists of anode, cathode and electrolyte. The anode is nothing but zinc can, zinc metal can. The cathode is manganese dioxide. The electrolyte is nothing but ammonium chloride, aqueous ammonium chloride, zinc chloride, starch paste. It can produce a cell voltage of, each cell can produce a cell voltage of 1.5 volts. The operating temperature is -5 to 45 degrees centigrade. This is the drawback. It cannot work at low temperatures. Let us move to the construction. The construction is nothing but it consists of anode, cathode and electrolyte. The anode of the cell is zinc can. Let us draw that. Draw the picture. This is the zinc can made up of zinc. This is a zinc can made up of zinc. It consists of number of layers. In between there is a graphite rod. In between there is a graphite rod. This is the graphite rod. Graphite rod surrounded by carbon powder and manganese dioxide powder, which acts as cathode. In the center of the cell, it consists of a graphite rod surrounded by carbon powder and manganese dioxide. This is the case was zinc case, zinc can. In between, it is filled with a paste of ammonium chloride, zinc chloride paste with starch. Is the paste which is also called separator, paste separator. Paste separator is made up of ammonium chloride plus zinc chloride plus starch, which is a paste separator. The separator between the anode and the cathode. Here the anode is zinc can. Zinc can acts as anode. Zinc can acts as anode. The graphite rod at the center, which is a support for manganese dioxide. Here the manganese dioxide is a cathodic material. And next, in between, The outermost layer was the acetate label. The outermost layer was the acetate label. It consists of number of layers. If we open the cell structure, this is the open cell structure. It consists of, at the top it is having metal cap which is a positive sign. At the bottom it is having metal bottom which is negative. It consists of number of layers. At the top it is having metal cap, at the bottom it is having metal bottom which is negative charge, at the center it is having graphite rod surrounded by the carbon powder and manganese dioxide and the zinc can. The outer layer was acetate label. The next layer of the acetate label was, which is called kraft, which is made up of paper, kraft paper. Inside there was an air jacket or air space. In between there is a plastic material. There is a plastic film, what we call as plastic film, which acts as an insulator. Plastic film which acts as an insulator. In between the kraft plastic film, there is an air space which acts as an insulator, and the final one is zinc can. Zinc can and the which acts as an anode, and the graphite rod which acts as cathode, which are separated by this starch paste. Not only starch, it is nothing but ammonium chloride, zinc chloride, starch paste which acts as an separator. This is about the overview of a Lachance cell. Let us move to the working of a Lachance cell. The cell reactions involved in the Lachance cell is the anodic half cell reaction, in which the zinc is going to be oxidized. Zinc metal is going to be oxidized as zinc metal ion plus 2 electrons. This is called as an oxidation reaction. This is called as an oxidation reaction. This is the metal which is solid in state is going to convert as zinc metal ions. It is going to release 2 electrons. The electrons moves from anode to cathode. At cathode, reduction of MnO2 takes place. The cathode consists of MnO2, 2 moles, 2 moles of ammonium chloride. The metal ions are moving from anode to cathode. The electrons are moving from anode to cathode. The reaction was reduction of manganese. Manganese is having plus 4 charge. Manganese is having plus 4 charge. Plus 4 charge is going to be reduced to plus 3 by gaining of electrons. Gaining of electrons is nothing but reduction. Mn2O3. Here the oxygen state was plus 3. Here the oxygen state was plus 4 and this is plus 3. Reducing the oxidation number is nothing but reduction. Zn NH3 twice Cl2. You can see this complex plus H2O. So 2 MnO2, 2 NH4Cl, zinc ions plus 2 electrons gives rise to Mn2O3, Zn NH3 twice Cl2 and H2O with generation of energy. The net reaction is zinc, which is a solid, 2 MnO2, which is a solid material, plus 2 NH4Cl, which is an aqueous in condition, which gives rise to both is nothing but redox reaction, both oxidation and reduction reaction, which gives rise to Mn2O3 plus Zn NH3 twice Cl2, which is, this is solid material, this is solid material, this is solid material, plus the byproduct is water. We are going to get the energy also. This is a primary battery. The electrochemical reaction or the redox reaction which is not reversible. The reaction is which is not reversible. So if you supply the electricity, the reverse reaction does not happen because this is a primary battery which is an irreversible battery. It cannot be recharged. It is an irreversible battery. The Lachance cell was a irreversible battery. Let us move to the next one. Applications of the Lachance. The advantages was lowest cost. The battery is the least expensive. Most of the people or most of the companies, they prefer the least expensive battery more than the performance. They recommend least expensive batteries than their performance in some cases. It is good for non-critical use under moderate conditions. At the moderate conditions, it is very helpful. It is available in various shapes and sizes. Applications. It is used in flashlights, portable radios, toys, novelties and instruments. The limitations are low energy density. It is having low capacity. The watt hour per kg is very low. It is having low energy density and its working was poor at low temperatures. Poor leakage resistance. Sometimes the battery will leak. Low efficiency under high current drains. Comparatively poor shelf life. At the period of 1945 to 1965, they have upgraded the dry cell of the Lachance with the paste of MnO2 and ammonium chloride. Till today, they have upgraded with a new battery called zinc air battery, which is having high shelf life, which is also a primary battery. When compared with zinc air battery, this is the primary battery. Zinc carbon battery is having poor shelf life and low capacity and low energy density. And the battery performance best under discharge loads. At this particular discharge loads only, the battery performance is good, is best. But its performance falls off sharply with increasing the discharge rates. If the discharge rate is very fast, therefore the performance fails. So, this is all about the Lachance advantages, applications and limitations. In today's class, we have discussed about the what's meant by Lachance. Lachance. What are the constraints of a Lachance? Is nothing but construction, anode, cathode, electrolyte and working. At anode oxidation takes place, at cathode reduction takes place. We have seen the overall reaction. This is the primary battery in which reversible reactions is not possible. Redox reaction together, in which reversible reaction is not possible. We have seen the advantages and applications. This battery was preferred because of low cost of low expensive electrolytes and zinc materials than their performance. In next class, we are going to discuss about the zinc air battery, which is a primary battery, which is having high energy density, high capacity and good shelf life, which is also used as a reserve battery. Thank you.